Hi, so we're going to start a unit on chemical equations. And this unit, that formula writing that we've been practicing and learning and working with is going to become really important. So we want to make sure that we have a solid foundation of that. If you are rusty at all with your polyatomic ions or formula writing, please come see me and please brush up on it, because now we are taking totally what we've learned in formula writing and applying it to a next concept. So we're going to take formulas and we're going to make them now into chemical equations. So we're going to start reacting different things together to see what they produce. So chemical equations are the process by which one or more substances are changed into one or more different substances. We took some of the basic idea of equations in our very first lab with the copper chloride. We learned some things about them. We learned that reactions are represented by a chemical equation, and we introduced this word of reactants and products. Reactants are what starts our reaction. Products are what's produced. In chemistry, we don't use an equal sign. We use this arrow, and this arrow means yields or produces. You can use either word, but we use this arrow. At some point, we'll start talking about equilibrium, and we'll talk about a double-headed arrow. But for now, all of our arrows are going to point to the right. We must have the same number and type of atoms on both sides of the equation. So we learned when we react, that was when we took the foil, and we put it in the copper chloride, and we made what we thought was rust, but rust had iron in it, and there was no iron produced. Instead, we actually produced copper. We learned a couple things about how we can't create new elements. We also can't lose elements. So any elements we start with also need to be at the end of our reaction. So we have a couple different types of reactions, and we're going to start by looking at 2 or 3 of them today. There's 5 in total. And so the first one we have is a synthesis reaction. So in a synthesis reaction, we have 2 reactants, and it makes 1 product. And that's sort of our key thing that we're going to look for. I'm also going to start showing you how to balance equations and what we look for when we do that. So an example we have here is NH3, which is ammonia, plus HCl, which is hydrochloric acid. It's going to form ammonium chloride. Now what we need to check is we need to check and see that we have the same numbers of elements on each side and types. So I have 1 nitrogen here, and I have 1 nitrogen here. So that's good. I have 1 Cl, and I have 1 Cl, and I have 3 hydrogens plus another 1, so I have 4 hydrogens, and I have 4 hydrogens. So everything checks out and everything is balanced out. And so this reaction is already balanced. Taking a look at another one here, I have hydrogen plus oxygen becomes water. Now we're going to talk a little bit more specifically about this, but there's a series of elements that when they are just the element by themselves, they like to be 2 of them. If you think about how they are most stable, we did a lot of diagrams in bonding about H2, O2, N2, and then all of our halogens. So the series of elements we refer to as the Hankel groups. And these are all the elements, and they're the ones that like to be 2s when they are by themselves. Not part of a compound, but not aqueous, when they are by themselves as gases. There are 7 of them, and they happen to make the shape of a 7 on the periodic table, which I can point out to you in class. But these are the elements that we refer to as diatomic. 2 elements. They like to be in pairs. And so you're going to need to know this. You'll hear me refer to them both on videos and class as the Hankel-Briffs, as using that as a sort of an adjective to describe them. But that helps us remember which ones we're talking about. So I look here and I have 2 hydrogens and I have 2 hydrogens. So I'm set. I have 2 oxygens and I only have 1 oxygen. So I'm not balanced. If I were to go ahead and put a 2 here, okay, I would be balanced, but this is no longer water anymore. We've just turned water into hydrogen peroxide. So that is a big no-no. We cannot change any formulas. So what is helpful, especially when people are learning to balance, is to put a blank in front compound or element. And in these spaces now, we can then balance. So if I have 2 hydrogens and I have 2 hydrogens, I'm good. I have 2 oxygens. The only place I can put a number is in front, so I'm going to put a 2 here. Now I have 2 oxygens and 2 oxygens, but what happened is I changed this. So we've looked at polyatomics, and we are all okay with this idea that if I have like AlNO3, 3, that this 3 distributes. Well, this 2 here distributes the same way. So now I have 2 times 2, or 4 hydrogens. So what number do I have to put here to make this also 4? Well, I'm going to put a 2 here. So now I have 4 hydrogens and 4 hydrogens, 2 oxygens, and 2 times the 1, 2 oxygens. We'll be practicing this a lot over the next week and a half. Now, I have silver plus sulfur, notice not a Hunkelbrief, so not diatomic, forms silver sulfide. 1 silver, 2 silvers, 1 sulfur, 1 sulfur. So again, I can put my blanks just to make sure that I'm clear. Well, I just really need to put a 2 here. Now I have 2 silvers and 2 silvers, 1 sulfur and 1 sulfur. And then I have Al plus Cl2 yields AlCl3. So I know my Cl's aren't good. So I'm going to go ahead and put that there. So since my Al is okay, I'm going to go ahead and deal with my Cl. Well, I have 2 here and I have 3 here. I can't make this into 3, and I can't make this into 2. So it's sort of like finding a common denominator, finding something in common. So if I put a 2 here, I can do 2 times 3 and make this 6. If I put a 3 here, I can do 3 times 2 and make that 6. Now I look, I have 2 ALs, so I'm going to go back and balance my ALs. Looking at all of this, make sure you notice that in this case, I have 2 reactants, 2 reactants, 2 reactants, and 2 reactants all there. And then if I look at the other side here, I have 1 product, 1 product, 1 product, and 1 product. And we're going to do one more type today. Decomposition. 1 reactant decomposes into 2 products. Same thing, we're going to practice our balancing. Here, look at this, I have that Hunkelbrief again, starting to keep pointing them out. So silver oxide becomes silver plus oxygen. Okay, and we're going to get to a point where I just give you this as the word silver oxide, and you have to write out the whole balanced equation. That's where we're headed by the end of this week. So I'll put my lines. I have 2 silvers and 1 oxygen. I have 1 silver and 2 oxygens. Let's take care of the oxygens first, because I know that's going to change my silver. 2 oxygens, 2 oxygens. Now I have 2 times 2 or 4 silvers, so I'll put a 4 there. Notice 1 reactant, 2 products. PCl5 becomes PCl3 plus Cl2. I have 1 P, I have 1 P, I have 5 Cls, I have 3 plus 2 Cls, so I'm balanced. 1 reactant, 2 products. H2O2 becomes H2O plus O2. Okay, not balanced. 2 hydrogens and 2 hydrogens, 2 oxygens, and 1, 2, 3 oxygens. So let's go ahead, and this is odd. If we put a 2 here, we can make that an even number. But now I have 2 times 2, which is 4 hydrogens. So let's check this out. 2 times 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. 2 times 2 is 4 oxygens. 2 times 1 is 2, plus 2 gives me another oxygen, so I'm balanced there. And then copper 2 oxide becomes copper plus oxygen, and notice Hunkelbrief, 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 Hunkelbrief. All of these here happen to be Hunkelbrief. Very, very common balancing equations. I have 2 oxygens, so I'm going to need to put a 2 here. That's going to make me need to put a 2 in front of my copper. So this is our first experience with balancing, and we're just going to look at these first 2 types. There are 3 more types to learn, but balancing will still be the same. Things to notice, I never was balancing very large numbers. Occasionally combustion reactions will have some larger numbers, but for the most part, if it's not balancing, check to see that your formulas are written correctly, or check to see that you're counting everything correctly. Typically, you can balance all equations with 2s, 3s, 4s, 90% of them. It doesn't take a whole lot of, we shouldn't be getting into 21s and 17s and that kind of thing. Like I said, occasionally with combustion, but for the most part, you don't need that. We will be practicing lots and lots and lots of balancing in class, and please brush up on that formula writing and polyatomics. It will really, really become important and imperative as we work our way through this unit.